All right, for the purpose of this video, we're going to talk about reference angles. All right, to start this off, let's look at the bell work. Again, the bell work is going to look at previous material that we've talked about that will lead up to the discussion of a reference angle. Okay, so number one here, graph the given angles in standard position. We're going to take that 1500 and I'm going to subtract 360. Okay, again, why is it 360? It's 360 because one full rotation is 360 degrees. So if I take 1500 and I subtract 360, I get 1140 degrees. And I'm going to continue to subtract 360 until I get between 0 and 359. I don't want to be at 360, but 0 and 359. So if I continue to subtract, I get 780. If I subtract again, I get 420. And if I subtract again, I get 60 degrees. Okay, to graph this in standard position, you're going to again have the initial side. I want to see this positive x-axis darkened and an arrow at the end that you have drawn, not the one that's already on the graph that's given. Okay, and then you're going to graph this angle here, whatever my leftover was, and if we're going in a positive direction, then I start here and I go up. So this would be at 90 degrees. Okay, and I only need to go to 60 degrees. So I'm going to be 30 degrees off of that, or about 2/3 of the way in the first quadrant. Okay, and if I go through and count my rotations, I have 1, 2, 3, 4 full rotations. So I start here and I go up again because it's positive. I go up and around. That's 1, 2, 3, 4, and then my extra 60 degrees. For number 2, my suggestion again here was to do what? It was to take the degrees of this instead of in radians, okay, to graph. So in order to do that, we're going to have to multiply this by 180 over pi. Okay, again, in order to change from radians to degrees, you multiply by 180 over pi. Okay, the purpose of that is because the pi's here will cancel out. All right, and then I have the -20, and then I'm going to divide this 180 by this 6 because it's nice and easy to do. So if I take 180 divided by 6, that's 30. So I have -20 times 30, which is -600 degrees. Okay, now here, because this is negative, I'm going to add. Again, for the purpose of adding, sometimes it might be easier if we avoid the negative and we subtract 360 and then go back and start tossing around the different signs. Okay, but here this is small enough, we're going to add 360. And that's going to give me -240 degrees. Okay, and that's between 0 and 359, be it positive or be it negative, and that's where I want to be. So now I'm going to go ahead and graph that. Okay, so again, my initial side here. Again, always the positive x-axis. And now that it's negative, I'm going to rotate now clockwise. So this is -90 down here. This will be -180 here. And this is -270. My -240 is someplace between 180 and 270. The question is where? Okay, it's 30 degrees off of the 270. So that again gives me this 2/3 of a way above here. Okay, I have one full rotation and then I have my extra. So I start here again. I go down now because it's negative, so I go down and around. That's 1, and then I finish it out with my extra. On the bottom there, I'm asking you to identify how many degrees are between the terminal side and the closest x-axis for each of the above angles. So if I'm talking about that, what I'm doing is I'm looking at this terminal side, or this terminal side, or the terminal side that you have, and I'm just looking at how many degrees between that and the closest x-axis. For this one, that would be the positive x-axis because it's a little closer here than it would be backtracking. So my angle between here and here is 60 degrees. Okay, and I know that because it goes from 0 and it goes up to 60. Okay. For this one now, this is actually closer now to the x-axis that's a negative one and not the positive one because the distance here is smaller than the distance here. So now I'm looking at the distance between here and here. Okay. This, I'm going to take 240 and I need to find out how many degrees from 240 to 180. So I can just subtract those. If I take 180 away from 240 or 240 minus 180, I get again 60 degrees. Okay, and that's all the bell work is asking for. Continue on to the lesson here. Review of some of the simple concepts that we've already talked about and discussed throughout this unit. The direction of rotation. If you are given a positive number, be it in degrees or in radians, then you are going to start with that initial side and your rotations are going to start going counterclockwise. In other words, you're going to go up first. If you are given a negative one at first, you are going to go clockwise. So again, you're going to start with that initial side and then you will go down. Okay, your starting point will always be where you place the pencil on the initial side and then rotate in the appropriate direction that was just mentioned. Changing from radians to degrees, like I stated for number 2 there, you're going to multiply by 180 over pi and change that to degrees because that's a little bit easier to work with. Reference angles, the topic of the day, are the smallest angle between the terminal side and the x-axis. In other words, that's exactly what we just did for bell work. When we found those two 60-degree angles, those were the reference angles. I still would like to see you graph these as you typically have and do the rotations and do the math, but I want to see that worked out and then find the reference angle. Okay, the usefulness of this, the values of the trigonometric functions are the same as the trigonometric values for the reference angles, given or taken a minus sign. Okay. So what that meant on the bell work is that 1500, if I took the sine of 1500, it would be the exact same value as the sine of 1140. It would then be the same value as the sine of 780. It would also then be the same as the sine of 420 or the sine of 60 degrees for my reference angle. Okay, that will lead to what will be known as the hand trick, which is the very next section in this unit. Okay, procedure-wise here, again, I just kind of like to throw out procedures most of the time. You can follow them or not. There's kind of a guide. Procedure for this, you're going to graph the given angle in standard position. Again, do exactly what we've been doing. Okay, then the second thing there, you're going to draw the line connecting the terminal side to the x-axis. So here, this is where I have a little bit of leeway. On the bell work, what I did was I just connected it with that orange line. I would suggest doing it in something that's a different medium or a different color. Okay, so that you can see where that angle is. And then I want you to label that as RA, okay, for reference angle, or you can write out reference angle, but RA would be fine, okay? So you'd write RA equals, and then find the value. So number 3 there, find the measure of the angle between the x-axis and the terminal side, okay? So adding to this in addition, you're gonna use very, very commonly 3 different numbers. You're going to use the value of 0, you're going to use the value of 180, and you're going to use the value of 360. Okay, and that is because those are the values on the x-axis, right? Doesn't matter if it's positive or negative, those are the 3 values that you will see. So you'll take whatever that leftover is, or wherever your terminal side will be, and you will either subtract them from 360 or 180, okay, or you'll use that 0. All right. Two examples. Okay, again, I'm going to graph these as if I was doing just angles in standard position. So I'm going to start here with the negative 1,250. I'm going to add 360 to it. When I add 360, I get 890 negative. I'm going to add 360 again. I get negative 530. I'm going to add 360 again, and I get negative 170 degrees. Okay. Again, this is between the values of 0 and 359 degrees, which means I can stop. Okay. I'm going to graph my initial side here. My extra here is then my terminal side, so again it's negative, so now I'm going down first, so this is negative 90 degrees. This is negative 180 degrees. So I can stop there as far as my labeling goes, because I only really need to get to negative 170, which is then how much off of here. It's very little, right? So we're going to have something, just a little sliver here. Okay. Again, how many rotations do I have? I subtracted 361, 2, 3 times. So I start here. I go down and around 3 times. I have 1, 2, 3, and then my extra. Okay, so before, this is as far as we went. We've graphed in standard position, and this is what I was looking for. We went 3 times in rotation. We have an extra 170 degrees, and then the problem was done. In order to find the reference angle here now, though, we need to find out how much space is between, again, the terminal side and the closest x-axis. This axis is closer than the positive x-axis, right? So I want to know the distance from here to here. So here I would take 180 because it's closest to the 180, and I would subtract 170, and that gives me 10 degrees. That is my reference angle. Number 2, now I'm giving this to you in radians so that we can again work on both sides here. If I do this, again, my suggestion was to multiply by the 180 over pi. So let's do that. 180 over pi. When I multiply those out, I'm going to cancel out my pi's, and that's going to give me, we can work it out here, we have 1,000. Try to multiply first. Get 31 times, I'm going to take 180 divided by 5, and that gives me 36. Okay, if I take 31 times 36, that gives me 1,116. Okay, and this is large enough positive now that I can just subtract sets of 360, or again, looking for my rotations. So I subtract 360. That gives me 756. Subtract again 360. That gives me 396. Subtract again 360, and that now gives me 36 degrees. Okay, so graphing wise, I'm going to again graph my initial side. The initial side is always again the positive x-axis. I'm going positive now because it was positive to begin with, which means I'm going up first or counterclockwise. This is 90 degrees then. Okay, and we're only at 36 for the extra, so I don't need to go further than that. 36 degrees is up a little bit. Halfway would be too much because that's 45. So I'm a little less than half. Okay, we'll call it there. I'm then going to graph my rotations. Again, I have how many rotations? I subtracted 360 3 times, which gives me 3 rotations. So I start here, and because it's positive, I go up first. I go up and around 1, 2, 3, and then finish it out for that remaining 36 degrees. Okay. Again, if this was just graphing in standard position, the problem would be done. However, we're looking for the reference angle. So again, I need to know how many degrees is between the x-axis and the terminal side. Okay, your values here should always be between 0 and 90 degrees. Okay, they can be 0 and they can be 90 degrees. Okay, but they cannot be anything higher. They will also always be positive, so make sure you pay attention to that. Even though number 1, we were working with negative numbers, this is a distance between the terminal side and the x-axis. Distance is always positive. So if I look at this one, I want the distance from here straight to there. Okay, which means I'm going to take this line, or the 0, and because I have 36, I'm going to take the 36, I'm going to subtract the 0, and that gives me a reference angle of 36 degrees. Okay, reference angles are not supposed to be that difficult. Again, my suggestion would be to maintain graphing in standard position, just so you continue to have that experience and that exposure. But then find the reference angle for these and make sure that you again identify it as RA, standing for reference angle. Okay, any questions, comments, or concerns, please again feel free to reach out to me.